Yeah. See this problem. In this problem, they have asked us to uh, find the waveform in terms of singularity function. Singularity function means it could be any basic function or the combination of uh, two or more, one or more basic functions. Understand that? Now, if you see this particular sawtooth waveform, okay, which they have named as V of t, okay, uh, this sawtooth waveform is combination of two basic functions. Okay, one basic function is the ramp, which you can see here. One basic function is the ramp, which has got the slope 5. Why do we need slope 5? Because at 1 it is 5. This ramp, if we see extended, this ramp is not extended. But if we extend the same ramp further, okay, you can see at 1 it is having the amplitude 5. At 2 it is having 10. At 3 it would be having the amplitude 15. Okay, which means that the slope of this ramp is 5. How to calculate the slope is actually the y-axis by the x-axis. See, if you take this particular point, it's 5, okay, divided by 1. So here delta y is 5, delta x is 1, so that would give you the slope equal to 5. Okay, so such a ramp we have considered. Okay, and where do I need this ramp to be existing? I don't want this ramp to be existing from 0 to infinity. Instead, I would rather want that extending from 0 to 1 only. Beyond 1 I want this to be 0. Okay, so if you want to limit the range to 0, I need to consider a rectangular waveform of amplitude 1, which would range from 0 to 1. Now, when I gave you these two waveforms, I asked you uh, which operation do you perform on these two signals, okay, so that you can construct V of t. Did anybody work on that? If you have worked, can you just unmute and express that? Anybody? I had given you these two signals, which is a ramp of slope 5 and a rectangular pulse, which is of amplitude 1 from 0 to 1. So what operation you would perform on these two to get the function V of t? Okay, everybody see here. Till now we have seen the operations considering the addition or the subtraction of signals. Okay, for the first time, let's multiply the signal. Everybody just see here. If you multiply these two signals, what's going to happen? Okay, see here. So what we are doing is we are doing 5r of t into u of t minus u of t minus 1 is what we are doing. So if you multiply these two, what we would get? See here. So from 0 to 1 it is 1. So 1 into anything would give you the same from 0 to 1, right? So it would give you this, because it is 1. 1 into this particular waveform would give you the same. Then anything multiplied by 0 is 0. So that's why from this point onwards, it would be a 0. Understand that? So what is this? This is actually the given V of t. Understand this point, everybody? Okay, so that's why we can represent our given V of t, okay, as this. Therefore, we can have our V of t equal to 5 times R of t into the rectangular pulse u of t minus u of t minus 1. So this is what is the mathematical expression for the sawtooth waveform that is given in the problem. Is this understood, everybody? Now let's what is asked express the sawtooth waveform in terms of the singularity function. That means you need to obtain the Laplace transform of this particular waveform. Okay, so we have expressed that in singularity function. After that, you have to, in the question, everybody just take down. After that, find Laplace transform of v of t. Okay, so let's find the Laplace transform of this singularity function. So therefore, to find Laplace transform of v of t, apply Laplace transform on the above signal, on the above expression, you can say. Okay, so if you apply Laplace transform, how is it going to look like? Is the question. So this implies that Laplace transform on the signal v of t would be, what would that be? What would that be? Laplace transform on this. You can keep 5 aside, okay, and apply Laplace transform on r of t into u of t. Okay, then again that 5 would also be there with this particular signal. Okay, then apply Laplace transform on r of t into u of t minus 1. Is this okay with you? Now everybody should understand r of t means it is t. Okay, why it is t? Everybody see here, at 0 it is 0, at 1 if it is 1 means this is actually t. R of t is t, but since this r of t is of slope 5, what would this r of t be in terms of t? At 0 it is 0, at 1 it is 5, at 2 it is 10. That means what is r of t? R of t is 5t. Understand that? So this implies that our Laplace transform on v of t would further look like 5 into Laplace transform on. Now r of t would become t, okay, multiplied by the unit step function minus 5 into Laplace transform of t into u of t minus 1. Okay, now there is something very important that we have to learn, something that we have not discussed so far. See here both the functions are consisting of t. That means both of these signals are functions of t, and both these are functions of t means there is t only. But here is t, but here is t minus 1. So that means this signal is valid, but this signal is invalid form. Okay, we cannot apply Laplace transform on a signal which is the combination of functions of t, wherein you will have one of the functions with t and another function with shifted t. Okay, if this is t minus 1, this should also be t minus 1, or if this is t, this should also be t. Okay, so I'll just give you just some examples regarding what is valid and what is invalid. See here, if you have t, let there be u of t. Okay, then this is valid form for application of Laplace transform. Okay, if this is t minus 1, okay, and if this is u of t, then it is invalid form. Fine. Or for that matter, if this is t and if this is u of t minus 1, then also it is invalid. Okay, so what is valid form? This. See here, everybody, if you have t minus 1 here, okay, you're supposed to have t minus 1 here also. So this is valid. Understand? So these two, the first one and last one, are the valid forms, because in first one both are functions of t, and in both the signals you have t only. Okay. Similarly, the last is valid because both are functions of t, and both functions of t are consisting of the shifted versions of t, that is t minus 1 as well as t minus 1 here. But what is wrong with the second and third one? One function is of t, the other function is of t minus 1. One is the function of t, the other is the function of t minus 1. So in that sense, okay, we cannot go with these two forms. Not that they're not signals, they are signals, but for application of Laplace transform, these forms would not be suitable. Okay, so we need to bring it to either this form or this form, either the first form or the second form. Is that okay with you? Now, there is no problem with this now. This is perfectly fine. The problem is with the second term, wherein one is the function of t minus 1, the other is the function of t. So either you should make this t minus 1 or this t. Okay, so that is what we need to look at now. Okay, so understand here, when u of t minus 1 is there, I cannot operate on this u t minus 1, but I can operate on this t. Understand that? Okay, so what I'll do is this, everybody just observe. So therefore Laplace transform on v of t further can be written as 5 into Laplace transform on t into u of t, okay, minus 5 into Laplace transform on. What I'll do is, see here, I want t minus 1, right? So I'll have t minus 1. To compensate this minus 1, I'll have a plus 1. Is that okay with you, everybody? Yes, you understand, right? What is happening here? Fine. So this is how we are supposed to be doing it. Fine. Then what? Then what? This is u of, you can keep this in bracket if you want. Then we have u of t minus 1. So this is how the things are. Get this point? So how can we further adjust this? Is the question. Okay. Everybody just observe this. So 5 into Laplace transform on t u of t. Okay, 5 into Laplace transform on this t minus this what we can write this as. We can write this as t minus 1 into u of t minus 1 plus or minus. Okay, this minus uh, or this would become plus. Okay, this would become plus rather, u of t minus 1. This is how the things are. Okay, so this is how we are supposed to be writing it. See, how did we write this as this? You should understand. How did we write that? See, which is the common point in these two? U of t minus 1 is common, right? So if you take u of t minus 1 out, what would be left within the bracket? T minus 1 plus 1. Everybody understand that? So this looks little confusing, but if you observe it carefully, okay, I have written this particular uh, wave as this particular expression as this. Okay, so some of you may get confused. How is that possible? So if you want to justify that, in these two terms, which is the common term? U of t minus 1 is the common term. Take that out. Okay, what would be left if you take u of t minus 1 common? It would be t minus 1 plus 1. So that is this. Okay, so you can work out that. If you don't understand, sit, look into it with patience, you'll understand. Okay, so how we can further rearrange this is this. So minus, this is equal to 5 into Laplace transform of t of u minus u of t minus 5 into Laplace transform on t minus 1 into u of t minus 1, okay, minus 5 into Laplace transform on u of t minus 1. This is by linearity property. Okay, you have two signals here and the Laplace transform can be applied like this. Thing is, I have already separated the scalar out. Okay, I already have separated the scalar. Fine. So instead, what could be done here is you can rather multiply these two. Okay, and multiply these two, bring it to this form, and then apply the Laplace transform. It's one and the same. Fine. So what happened is I instead of bringing it to the required form and then applying the Laplace transform, what I did is initially itself I applied the Laplace transform and then tried getting this into the proper form. It's one and the same. Okay, you can do it the way you want. Now the things are in place. Okay, so what is this? It is 5 into what is Laplace transform of t? See, u of t is with another function of t. That means this u of t is just a range defining function, which is the actual signal here. T is the actual signal. So what is the Laplace transform of t? It is 1 by what? S square minus 5 into what? Which is the basic signal here? T is the basic signal. Okay, but this t is the shifted version of t. So what is the shift? Minus 1 is the shift. So you will have e power minus s here to compensate that shift. Okay, this is by which property? The time shift property. Understand? Then you have minus 5 times what is this? T minus 1, right? So let me write this properly. This is t minus 1. U of t minus 1. Okay, so what would that be? What is the Laplace transform of u of t? It is 1 by s, right? So 1 by s, but there is a shift, so it is e power minus s by s. Understand that? So this is what is the Laplace transform. Okay, so Laplace transform on v of t can be written as, what is common there? 5 is common, right? So 5 you can take common. Fine. So what would be left out? 1 by s square minus e power minus s by s square minus e power minus s by s. So this is what it is. Is this okay with you, everybody? So what is tricky here is getting the given expression in the proper valid form. Okay, so this is what is the lesson learned here. So we need to bring the equation. We can have the expression in this form, or you can have the expression in this form. We cannot have it in these two forms. If you have it in these two forms, somehow you need to see that you get this expression in these two. Okay, so that is what you would be doing rather. Okay with that? Now let's move on to another problem. Let's move on to another problem, that is this. Problem number 3. Problem number 3, everybody. Okay, express, take down the statement, everybody. Express f of t in terms of singularity function and find Laplace transform and find f of s, they'll say. That means they'll be giving us f of t. We have to find f of s. That means you need to apply Laplace transform on f of t to obtain f of s. Okay. Fine. Everybody take down this particular waveform. the expression, let's take it from here. Okay, this is 0, 1, 2, 3. Okay, so should go to then, yeah, this is how the waveform is. This is 3. Okay, and this is -3. Fine. So 0, 1, 2, 3. At 3 it hits the negative max. At 0 it hits the positive max. Okay, and it again goes to 0 at 3. Fine. So everywhere else it's 0. Everywhere else it's 0. So this is what is the waveform, and they have named the waveform as f of t. So this is the expression. So there are two parts in the expression. They are lines. Let's call them as lines. Okay. So this is line number 1. Everybody understand? Okay. I'll be rewriting this. I hope everybody has copied this. I'll just be explaining you the things. Just listen to it first before going with the solution. See here. 0, 1, 2, and 3. Okay, call this as line 1. Line 1. Okay, so this is line 2. Everybody understand this? So this waveform is composed of 2 lines. Okay, now let's everybody understand this very simple form. Now, can you give me the equations for line 1 and line 2 is the question. Can you give me the equation for line 1 and line 2? Okay, now see here, to find any to find the expression for any line, you need to find out at least 2 points on that line. Okay, 2 points on the line. So let's consider the 2 points on line 1. Okay, let's consider this particular point. So the two coordinates, the xy coordinates of this particular point. What is that? X-axis is 0, then y-axis 3. So it's 0, 3. Okay, let's have another point on the same line. So this is line 1 only, right, till here. So this is part of line 2 also, but let's take this as a common point. 2 is the x-axis and y is -3 is the y-axis. So we have found out 2 points. Understand that? Now this 0 what you have, let's call this as x1 and this as y1. Okay, let's call this as x2 and this as y2. So what we do now is to find expression for line 1. What is the equation that we use to find the equation for the lines? Okay, that is this. Everybody do this. Consider y minus y1 divided by x minus x1. Okay, similarly y2 minus y1 divided by x2 minus x1. Okay, so this y here is what? Y-axis. What is y-axis here? Y-axis is f of t. See here, y-axis is the function of t that is represented as f of t. Okay, what is x? X is the x-axis, which is time axis here. See here, it is time. So here also we should write. So y is f of t and x is time, and the rest x1 y1 is these 2 points. x1 x2 y2 is this particular point. Understand that? You just need to substitute that and obtain the equation for line 1. Fine. So get me that, everybody. Y is f of t, y1 is 3 divided by x is t, okay, and x1 is 0. This is how it comes. Then y2 is minus 3, y1 is 3, okay. Similarly, x2 is 2 and x1 is 0, okay. So if you work out this, you would get your equation for line as f of t equal to f of t equal to 3 minus 3t. Okay, what is this? This particular line 1. Line 1 expression is obtained as 3 minus f of t equal to 3 minus 3t. And this is 3 minus 3t from where to where? From 0 to 2. Okay, so f of t is 3 minus 3t for t greater than 0 and less than 2. So f of t we have obtained from 0 to 2, that is 3 minus 3t. Now the similar exercise needs to be performed to obtain the expression for line 2, which I'm not doing. Okay, so you can do the same with this particular expression. So I'll give you that. Similarly, expression for line 2 is obtained as, what is it obtained as? It is obtained as f of t equal to minus 9 plus 3t for t greater than 2 less than 3. Okay, so we have obtained f of t, okay, for range 0 to 2 and for range 2 to 3. So if you write the combined form for f of t, it looks like, therefore f of t can be given as what? 3 minus 3t for t greater than 0 less than 2, okay, and f of t is minus 9 plus 3t for t greater than 0 less than 3. Fine. And everywhere else, leaving these two ranges, what is f of t here? From minus infinity to 0 it is 0, and from 3 onwards it is 0. So what we can say, so we have to say that f of t is 0 elsewhere. Elsewhere you can write, or you can write otherwise. So this is the exercise one should do before getting into finding out the Laplace transform of f of t. Okay, so see here I have taken 3 problems. Okay, in the first problem the signal was expressed in terms of the unit step function. In the second problem the given function was expressed in terms of the ramp and the unit step function. In the third problem the function is expressed in terms of lines. Okay, so you should understand which is the basic signal hidden in the given waveform. Get that point? Okay, so now we have to first bring it to the proper form, okay, so that we can apply the Laplace transform. Okay, so we are saying it is 0 to 2, right? So if we say it is 0 to 2, okay, how can we, which waveform is 1 from 0 to 2? Can you tell me a waveform which is 1 from 0 to 2? Anybody? Anybody? Do you know a waveform which is 1 from 0 to 2? It is this. What I mean is this here. I mean this. I need a waveform which is 1 from 0 to 2. Anybody would like to give the expression for this? You can unmute yourself. Don't give it in chat. I'll not be able to look into the chat. So if you say, we can easily discuss. Yeah, which is this function? Which is
U of t minus U of t minus 2.
very good. It is u of t minus u of t minus 2. Okay, so this is 1 from u of 0 to 2 means this particular waveform is actually u of t minus u of t minus 2. Right. Similarly, if I want a waveform which is 1 from 0 to 3, say, okay, 0, 1, 2, 3. So which is this waveform? This waveform would be u of t minus u of t minus 3. Right. So see here, if this 3 minus 3t, what you have, if you multiply this by this, it means that 3 minus 3t is actually ranging from 0 to 2. Everywhere else it would be 0. So you understand how is this helping us to define the range of the signal? Okay. And similarly, if you want a signal to define this range, what you would do? You would multiply this particular function of t from this rectangular wave, which is 0 everywhere else other than the range 0 to 3. Okay, so I want this to be existing from 0 to 3 and I want this to be existing from 0 to 2. So what I can do, I can express this as, therefore f of t can be given as 3 minus 3t. It is of range 0 to 2. To say that the range is 0 to 2, we multiply this signal from u of t minus u of t minus 2. Okay. Similarly, the second signal is what? It's let's write 3t minus 9. Okay, so this is ranging from 0 to 3. So how to make it range from 0 to 3 using a unit step function? By multiplying this particular function by u of t minus u of t minus 3. So this is how we get the particular function f of t into the required form.
Sir,
Yeah,
f
go
of
on.
t is equal to 3t minus 9 when t ranges
Uh,
from 2 to 3, right?
from yeah, from 2 to 3, isn't it? Very sorry.
Yes.
Yeah. I'm doing it from 0 to 3. Yes. That's from 2 to 3. Very sorry for that. Okay, so what is that we are supposed to be doing is this goes from 2 to 3. Okay. So which waveform do we need to be multiplying here? Anybody? Yeah, this is from 2 to 3. Which is the waveform which exists from 2 to 3 here?
U of t minus 2 minus U of t minus 3.
Yeah, just a minute. I want a waveform which is from 1 from 2 to 3. U of t minus 2, right? Which is this waveform? This is u of t minus 2 minus u of t minus 3. So this would give you a waveform which is 1 from 2 to 3. So I need to change the things here. It is u of t minus 2 minus u of t minus 3. So this is how the f of t looks, and we need to apply the Laplace transform to this. F of t is obtained like this. Now let's see how it can be adjusted properly so that the application of Laplace transform would become easier. So let's do that mathematical operation so that this would come to the proper form. Let's move on now. This is f of t. Let's multiply it. Okay, the expression would become big. but let's move on with it. It's 3 into u of t. Everybody keep going with this. 2, then we have minus 3t into u of t. Okay, then minus into minus plus 3t into u of t minus 2. Okay, then let's start from here. Plus 3t into u of t minus 2 minus 3t into u of t minus 3. Okay, similarly minus 9 into u of t minus 2 plus 9 into u of t minus 3. So this is how the things happen to be. Now in this, the first two terms is not a problem because in first two terms there is just one function of t. Similarly, in last two functions, you have just one function of t because these two functions of t are with the scalars. Here the scalar is 9, whereas here the scalar is 3. So the first two terms and the last two terms are not at all problems. Okay, and see the third term here. Though there are two functions of t, okay, the first one is t, the second one is also function of t. The first function is the function of t, the second function is also function of t. But here see what's happening in the fourth term. The first function is function of t, whereas the second function is function of t minus 2. Okay, so this needs to be altered. Okay, similarly here you have t and here you have t minus 2. This needs to be altered, and similarly this. So these three terms need to be altered before the application of Laplace transform. Is that okay with everybody? So let's move on that. You can do it yourself voluntarily, okay, and you can just compare the result at the end. Those who have not understood the things, okay, see how that can be done. Let's have f of t. Okay, let's keep 3 u of t as it is and 3 into u of t minus 2 as it is, because absolutely there is no problem, and also there is no problem with this 3t into u of t. Okay, now here is something that we need to be careful about. That is, here this is t and this is t minus 2. So this also needs to be t minus 2. That means what I need to do here to this t, I need to add and subtract 2 here in this particular place. Okay, so we'll have a term t minus 2. Okay, so how to do that? It's 3 into t minus 2 plus 2 u of t minus 2. This is how the things go. Okay, then let's come here. Plus 3. Okay, so there are two such terms, right? What is that? See here, you have 3t into u of t minus 2, and again you have 3t into u of t minus 2. Is that right, or I did mistake somewhere? Just see that 3 into u of t, 3 into u of, then minus 3t u of t minus 3t. Okay, this is this plus 3t u of t. That's fine. Then this is plus 3t u of t minus 2. So it would become 6, right? Okay, so these two are same. These two are same. Okay, so it's as good as doing this, everybody. So you have two such terms. So here instead of 3 we shall write 6, because you have 3t u of t minus 2 and 3t u of t minus 2. Okay, so that would become 6t u of t minus 2. So I have taken care of that in this way. Okay, then you have minus 3t u of t minus 3. Do you have that anywhere? No, no. So we should handle that now. Okay. Now this is what we are looking at. It's minus 3. This t minus t should become t minus 3. That means t minus 3 plus 3 into u of t minus 3. Okay. Then absolutely no problem with these two. 9u of t minus 2. So this here is u of t minus 2 and here is u of t minus 2. So these two can be clubbed together, right? So we shall see for such terms now, if there are any such repetitive terms. This is 9u of t minus 3. Any u of t minus 3 uh, as the only function of t. Let's see that. Okay. So these two let's club. Which two? Yeah. These two can be clubbed. Okay. So therefore, you need to be little careful regarding the operations because there are too many terms to handle. So you can make mistakes here. So let's be very careful. So this and this is what we have clubbed. Okay, here this and this is what we have clubbed as the 16 to u of t. Fine. So what is left is this minus 3t u of t. Okay, so how would you handle this particular term? Everybody just see here. It's 6 into, okay, t minus 2 into u of t minus 2. Okay, then plus 12 into u of t minus 2. So see, these two terms should give me this term. How is that? So which is common term among these two? U of t minus 2 is common, right? Take u of t minus 2 common. Okay, or 6u of t minus 2 is common. So if you take 6u of t minus 2 common, so what will be left behind? There would be what? T minus 2 plus 2. Okay, so these two are fine. Similarly, can you take care of this? How to write this term? Minus 3 t minus 3 into u of t minus 3. Okay, then minus 9 into u of t minus 3. Okay, then you have plus 9 into u of t minus 3 here. So these two would go off. So what is left behind is this particular way, this particular thing. So in this, is there anything that we can club together? So see here, there is minus 12 and plus 12 u of t minus. So these two would also go. So then you have yeah, I think that's it. So finally what you have as your f of t. So this is a cumbersome procedure, but something that everybody can do if you practice. It's 3 into u of t minus 3t u of t plus 6t minus 2 u of t minus 2. Okay, then minus 3t minus 3 u of t minus 3. So this is what is your f of t finally. Okay, so this is how your f of t looks like. Fine. Where did we start? We started here. Okay, so we started from two lines. Okay, the two lines were having different ranges. One line was ranging from 0 to 2. The other line was ranging from 2 to 3. Okay, we found out the line equations and multiplied those by these two functions. Okay, so that is how we started arriving at this particular equation. Fine. Now applying Laplace transform can be done easily. U of t Laplace transform we know because that's a standard transform, and here t u of t is there. Since u of t is there with another function of t, this is just a range defining function. So we need to be looking at only t. So it is 1 by s square. So here the basic function is t, so it is 1 by s square, but there is a shifted version of t, so it is e power minus 2s. That exponential needs to be accompanied here. Okay, so can you write it yourself now? Do that, apply Laplace transform on this. Okay, so by which property we doing this? We know that x of t minus t naught is actually equal to Laplace transform of x of t minus t naught is actually equal to e power minus t naught s into x of s. Okay, so therefore Laplace transform on, call this as equation number 1. Okay, on 1 implies what? F of s 3 by s, because Laplace transform u of t is s, minus 3 by s square, because Laplace transform of t is 1 by s square. U of t is just a range defining function here, plus 6 into shift is there. The shift is minus 2, so it's e power minus 2s is the shift, and the basic function is t, so it is divided by s square. So and it's minus 3. Okay, the shift is minus 3, so it's minus 3 e power minus 3 is divided by s square. So this is how the things happened. Okay, so this is f of s which they wanted us to find out for the given function. Okay, with that, everybody. So if you work it yourself, this is little lengthier, but these are all problems which appear in the exam. Okay, so if you just understand and work out once, okay, and if you are good with how to obtain the equation for lines, or how to express the given waveform in mathematical form, if you're aware of all those things, then you can easily arrive at the result like this. Fine, so let's move on with another waveform. Okay, so this is third waveform we have seen, so let's go on with the fourth waveform. Fine, everybody take down this fast. Again the same, express, everybody just copy down this, express f of t using singularity function and find what? F of s. So the given f of t is this. Everybody copy this down fast. The waveform is 0 from 0 to 1. It goes to minus 1 at 1. Okay, and at 2 it is minus 2. At 2 it is minus 2. Okay, so this is how the waveform looks like. So this is what is the waveform. Fine, and this waveform they are called as f of t. This is minus 1, this is minus 2. Okay, and this is axis, time axis. This is what is the waveform. Now there is again a ramp involved, but it's with negative slope. Okay, there is a ramp involved. At 1 it is minus 1, at 2 it is minus 2. Everybody understand that? At 1 it is 1, at 2 it is minus 2. Okay, so one waveform is the ramp, okay, which goes like this. One waveform is the ramp, but that ramp should exist only from 1 to 2. Okay, so what you would do if you have to do it, if you want that negative ramp okay, to be existing only from 1 to 2. So which waveform you would bring there for multiplication is the question. So everybody just look at this. First, let's consider the ramp which is going negative from 0 here. Okay, so let's consider this, and let's say this is that ramp. Okay, it just goes on and on. Fine. At 0 it is 0. At 1 it is 1. Sorry, at 1 it is minus 1. At 2 it is minus 2. So what do you think this is? What do you think is the wave? This is r of t, but I cannot call it as r of t. I can call it as minus r of t. And since it is minus r of t, this can be minus t. See here. At 1 if it is 1, and if 2 if it is 2, I would say that particular function is t. So at 1 if it is minus t, at 2 if it is minus 2, okay, this is t. At t equal to 1, it is minus 1. At t equal to 2, it is minus 2. That means what is the waveform? It is minus t. Is that understood? So this particular waveform is minus t. Is that understood? Now, which waveform you need along with this? Which waveform do you need along with this? So you need this waveform for multiplication. See here, everybody, I need a waveform which is one from 1 to 2. See here? So this is the part of the ramp I need. Okay, so that means you need a waveform which is one from 1 to 2. Okay, 0, 1, 2, like this, and this is 1 here. So which is this waveform? Now you're all experienced, you can easily say which this waveform is. This waveform is u of t minus 1 minus u of t minus 2. So this is minus t, this is u of t minus 1, okay, then u of t minus 1 minus u of t. So which operation do you perform on these two, okay, so that you will find the given f of t? Which operation you will perform, anybody? Which operation needs to be performed on these two so that you will get this given waveform? See here, if you multiply these two signals, we'll get that, because see here, from 0 to 1 it is 0, so 0 into any signal would give you 0. So from 0 to 1 you'll have 0 signal here, that means no signal. And from 2 onwards this particular signal is 0, so you're multiplying this signal from 0, from 2 onwards. Okay, so this portion would also be 0. So you'll only be left with this signal, okay, from range 1 to 2, because from 1 to 2 is only 1. Okay, so 1 into any signal would be the same. So multiplication of these two. Okay, so it looks like this. See here. Everybody see here. So just extend this down. Say minus t into u of t minus 1 minus u of t minus 2. Okay, so if you do this, you will end up getting this. What is this? This actually is your f of t. 1 minus 1, 2 minus 2, and everywhere else it is 0. Understand that? So what you can say, therefore f of t can be given as minus t into what? You're multiplying this into u of minus t minus 1 minus u of t minus 2. Okay, now again bring this to the standard form as we have done with the other functions earlier. F of t is now given as minus t into u of t minus 1. Okay, then minus into minus plus t into u of t minus 2. Both are invalid functions, so we need to make them valid. How? By turning this into t minus 1 and turning this into t minus 2. So how to do that? Keep this t minus out, say t minus 1 plus 1 for compensation. U of t minus 1 is what is left there, plus t minus 2 plus 2 into u of t minus 2. Okay, so now what you would do, break them into multiple signals. Okay, so how would you do that? You have u of t minus 1 plus 1. Okay, so this can be written as minus of t minus 1 into u of t minus 1 minus u of t minus 1. Okay, plus t minus 2 into u of t minus 2. Okay, plus 2 into u of t minus 2. So this is how the things happen to be. Okay, now apply the Laplace transform. This is your f of t ready for the application of Laplace transform. Fine. So how does it look like? How does it look like? Everybody do that. Applying Laplace transform implies what? Implies f of s is equal to minus e power minus s divided by s square. Why is that so? Anybody? Why it is e power minus s? Because it's a time shift and the shift is minus 1. Since the shift is minus 1, in the numerator you need to have that exponential e power minus s into the Laplace transform of the basic signal, which is the basic signal. T is the basic signal, not u of t. T is the basic signal. Okay, so 1 by s square. Okay, similarly here, this is also a shifted version. Okay, but which is the basic signal? Basic signal is u of t minus 1. So it is minus e power minus s divided by s. You understand the difference between the first and second? In the first, the signal is actually t minus 1. In the second, the signal is actually u of t minus 1. I'm again and again telling you, if a unit step function is there with another function of t, that unit step function is just a range defining function, not the actual function. Understand, the actual function is t minus 1. Here the actual function is t minus 2. What is this u of t minus 2 doing here? U of t minus 2 is defining the range of this t minus 2. And it tells that this t minus 2 is existing from 2 to infinity. Is that okay? So you need to be a little careful regarding those functions. Plus the third. Okay. So the shift is minus 2. So it's e power minus 2s divided by s square plus 2 into e power minus 2s divided by s. So this is how it's going to look like. Yeah. So these are the problems which we had to solve in the waveform synthesis. Okay, so after this we have the periodic signals, wherein we'll be having the patterns repeating. So if you have repetitive patterns, okay, how to solve such problems? Okay, we will look at that in the next class.